We start with Ohm's law, which shows the basic relationship between voltage, current, and resistance in an electrical circuit. According to this law, voltage is equal to current multiplied by resistance, written as V equals I times R. If you know the voltage and resistance, you can find the current using I equals V divided by R. Similarly, to find resistance, use the formula R equals V divided by I. Next, we move to power formulas, which tell us how much electrical energy is being used or produced per unit time. The basic formula is power P equals voltage times current, or P equals V times I. But power can also be calculated in two more ways. Using current and resistance, we get P equals I squared times R, and using voltage and resistance, we get P equals V squared divided by R. Then comes energy, which is the total work done by electricity, and it is calculated as E equals power times time, or simply E equals P times T. Moving on to series circuits, where all components are connected end to end, the total resistance is the sum of all individual resistances, written as R total equals R1 plus R2 plus R3, and so on. In series, the voltage also adds up, but the current remains the same through each component. In contrast, in parallel circuits, the components are connected across the same voltage source. The total conductance, which is the inverse of resistance, is the sum of individual conductances. To find total resistance in parallel, we use the formula 1 divided by R total equals 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, and so on. In parallel circuits, voltage remains the same across each branch, but the total current is the sum of individual branch currents. Now let's understand capacitance, which is the ability of a component to store electrical charge. It is given by the formula C equals Q divided by V, where C is capacitance, Q is charge, and V is voltage. Another way to calculate capacitance is using the formula C equals epsilon times A divided by D, where epsilon is the permittivity of the material, A is the overlapping area of the plates, and D is the distance between them. Moving forward, we have inductance, which is a property of a coil that opposes the change in current. When the current through a coil changes, it induces a voltage. This is written as V equals L times D by dt, where L is inductance and D by dt is the rate of change of current. Inductance can also be calculated as L equals N squared times mu times A divided by L, where N is the number of turns, mu is the permeability of the core material, A is the cross-sectional area, and L is the length of the coil. Finally, we look at frequency and time period, which are important in alternating current systems. Frequency, represented by F, is how many cycles occur in 1 second, and it is the inverse of time period. So,